All right, today we're going to answer the question, how do we find slope? Well, to begin, we have to ask ourselves, what is slope? Slope is the ratio of vertical change to horizontal change. Okay, and we remember vertical is our up and down, horizontal is left and right. We give it this letter M, and we say, okay, the slope M is the vertical change to the horizontal. So vertical, those are our y values. So we have these 2 points, y2 minus y1, over the change in the horizontal can be found between 2 points with x2 minus x1. And basically what we're doing here is just the rise over the run. Okay, so let's try to do an example of that. So I'm going to try and find M. And notice that M equals y2 minus y1 over x2 minus x1. So I need to define which is going to be y2, y1, x2, x1. So my first point here, I'll make this my x1 and y1. And notice x1 and y1 have to go together. The same goes for x2 and y2. So now M equals y2 is 7 minus y1 of 3. x2 is 6 minus x1 is 1. So that's 4 over 5. I check if it reduces. It doesn't. So the slope through those 2 points is 4 over 5. Whenever we're classifying slopes, they can fall into 4 categories: positive, negative, 0, or undefined. These first 3 slopes would still be a function, whereas undefined, if you have an undefined slope, you don't have a function. So let's look at this. A positive slope rises from left to right. So you can probably guess that a negative slope falls. A 0 slope is a horizontal line. For a horizontal line, the y value never changes. So this always looks something like y equals just some number. The last undefined slope is a vertical line up and down. This is whenever the x never changes, and it always looks like x equals a number. And remember that this is not a function. So just to investigate these last two, the 0 and undefined, a little bit more, whenever we have a 0 slope, if m equals 0, that comes from there's no change in the y values. So the y2 minus y1 would be 0, whereas the x values change a whole lot, right? So 0 over any number is equal to 0. Now in the vertical undefined slope, we could have our m is equal to the y values are changing constantly. So we have, just some number, but now the x value never changes. So the run for rise over run is 0, and we can't divide by 0. So we call this undefined. Okay, so now we're going to try and classify some slopes. So what I want you to do is pause the video and try on your own to use the equation that we learned before, the y2 minus y1 over x2 minus x1, with these points, and try to classify these as positive, negative, 0, or undefined. So go ahead and press pause now, and we'll get back to this in a moment. All right, if you did these problems correctly, the first slope you should have got is 3 over 0. Remember that we can't divide by 0, so this is an undefined slope. If it would have been 0 over 3, however, that would have been 0. On number 2, we had a slope of positive 5 over 7, so this is a positive slope. Okay, now slope can be used to represent an average rate of change, or how much one thing changes on average relative to another thing. A slope that is a real-life rate of change involves units of measure, such as like miles per hour or degrees per day. So we're going to do an example of that. Okay, so here we have 2 points, 212 and 530. And we're going to find the average rate of change between them. But here, x is measured in hours and y is measured in dollars. So we're just going to take the slope just like normal. We have m is equal to our y2 minus our y1 over the x2 minus x1. So here we have 30 minus 12 is 18 over 3. So this is 6. And let's look at what the y's are measured in here. We have that the y is in dollars. And in the top of our slope, we have the y. So we have, this is $6. And then we're dividing by the x's. So we're dividing by the hours. So $6 per hour. And that's an example of an average rate of change. Just that the y's are always in the numerator, and it'll always be the y measurement per the x measurement. All right, so now let's talk about the slopes of parallel and perpendicular lines. Parallel lines, we know that on a graph, there are two lines that would never intersect. So let's just look at this example here. We notice that these are both positive, and for them to never intersect, their slopes must be equal. So for parallel lines, we say that M1 would equal M2. The slope of line 1 is equal to the slope of line 2. And perpendicular lines are a little different. So let's just draw an example of some perpendicular lines. Perpendicular lines intersect at a 90 degree. Okay. Now the slopes of perpendicular lines are opposite reciprocals. So what does opposite reciprocals mean? Well, the opposite means that you should change the sign. And what I mean by that, like, look at this line right here. This is a positive slope. It's the perpendicular line to it would have a negative slope, so we would have to change the sign. And the reciprocal just means that you would flip the slope over. So if you had, in general, we say that M1 is equal to the negative 1 over M2. I think that's a little bit easier to see with an example. So if you had a slope of 4/3, the perpendicular slope, so we can say the slope perpendicular, this is the symbol for perpendicular, is equal to, change the sign, it was positive, so now it's negative, and flip, 3/4. If you had a slope, your original slope was -2. The perpendicular, we know now it's going to be positive. And just remember that any number that doesn't have a denominator is being divided by 1. So if we flip this over, this is positive 1 over 2. Okay, here once again we're going to pause the video, and you're going to try to answer the question, are these two lines parallel, perpendicular, or neither? When we have the first line goes through the points -3, -1, and 2, 5. And line 2 would go through 3, -4, and -3, 1. So in order to do this problem, you're going to have to find the slope of each of the lines, so of line 1 and line 2, and then compare those slopes. So go ahead, press pause, and then we'll join back up in a second. All right, the slope of line 1 was 6 over 5, whereas the slope of line 2 was 5 over -6, which is the same thing as just -5 over 6. And so here we see that each of these have been flipped. We have one positive and one negative. These are opposite reciprocals. So these two lines must be perpendicular. All right, and that's finding slopes of lines.